All right, so get this. Today we are going deep, deep into zero-knowledge proof. Have you heard of it?
Oh, yeah, it's really interesting stuff. Really interesting.
It kind of sounds like science fiction, right?
Yeah.
Like, how can you prove something without, actually revealing what it is you're proving?
Well, that's the whole idea. It's all about proving, something without giving away the information itself.
But we've got some pretty interesting sources today that dive into this. I mean, we're talking about applications in secure messaging, blockchain tech, even some real-world examples I had never even heard of before.
Right. Yeah, it's becoming more and more important these days.
So maybe we should start with the basics, right? Just what exactly is zero-knowledge proof?
Okay, so zero knowledge proof, it's like imagine this one person, we'll call them the prover, wants to convince another person, the verifier, that they know something, but without actually revealing, what that something is.
So kind of like I could prove to you I know the password to my bank account, but I never actually have to tell you what the password is.
Exactly. Like you can prove you solved a Sudoku puzzle without showing the solution. That's zero knowledge proof in a nutshell.
Okay, that makes sense. That makes a lot of sense. But then how does that actually work in practice? Like,
Yeah.
when we think about things like online security, for example, how does that play out?
Well, think about authentication, for example. Right now, you have to type in passwords for everything.
Oh, tell me about it.
But with zero knowledge proof, you could prove your identity like knowing a password without actually giving away the password itself.
Wow, so no more worrying about data breaches and stolen passwords?
Potentially, yeah.
That would be amazing. That would be
Yeah.
revolutionary. But how? I mean, it still sounds kind of like magic to me.
Well, it's not magic, it's math. Pretty complex math, to be honest. It's based on cryptography, which is basically the science of secure communication.
Okay, so cryptography, zero-knowledge proof, they all kind of go hand in hand.
Yeah, definitely. See, with zero knowledge proof, you have the series of interactions between the prover and the verifier. And these interactions create a sort of mathematical puzzle that the prover can only solve if they have the secret knowledge.
So it's kind of like a challenge then, like prove to me you know this thing without telling me what the thing is.
Exactly. And the cool part is the verifier can be absolutely sure that the prover knows the secret without ever learning what that secret is.
That's incredible. I mean, it's kind of mind-blowing when you think about it.
Yeah.
And speaking of mind-blowing, one of our sources talks about this software suite called Spot On. And they are doing some really interesting stuff with zero-knowledge proof.
Oh yeah, spot on. It's a really cool example of how this tech is being used in the real world.
So what is it exactly?
Well, it's described as a secure instant chat messenger, an encrypting email client, kind of a whole suite of tools,
It sounds pretty comprehensive.
Yeah, it is. But the big thing that caught my eye, the thing that's relevant for our deep dive today, is the way they use something called secret streams to secure communications.
Okay, secret streams. I like the sound of that already.
Yeah.
Well, what are they?
So imagine like a secure channel for transmitting information. What makes it so secure is the way they generate the keys for these streams. It's done through this whole zero-knowledge process, meaning those keys are never actually sent over the internet.
Hold on, so the keys never actually travel across the web.
Nope.
That's incredible. So it's like you're creating this secret tunnel for your data. And because the instructions for building the tunnel were never shared in the first place, hackers can't intercept them.
Exactly. It's a brilliant way to minimize the risk of your keys getting compromised during transmission.
Which, if I'm remembering correctly, is a big problem with a lot of encryption systems, right?
Huge problem, but Spot On bypasses that entirely.
Okay, so they've got these secret streams locking down your data. But it sounds like they're not stopping there. Our sources mentioned something about a cocktail approach to encryption.
Oh yeah, that's another really clever thing they do. They don't just rely on one single encryption method, they layer them, like different algorithms applied one after another.
So it's not just one super strong lock. It's like having multiple locks, each one needing a different key.
That's a great way to put it.
Wow, that's really impressive.
It makes it so much harder to crack. And, with quantum computing on the horizon, which is a whole other can of worms, this kind of multi-layered security is going to be even more crucial.
Right, because quantum computers could potentially break a lot of our traditional encryption methods, right?
Exactly. It's a real concern. But Spot On is kind of getting ahead of the curve with this approach. And they even combine different types of encryption, like AES and McKinney's.
Okay, I have to admit, you've lost me a little bit there. AES and McKinney's.
So AES is the Advanced Encryption Standard. It's like the gold standard for symmetric encryption. Then you've got McNeely's, which is asymmetric and based on this whole other thing called algebraic coding theory.
Right, well, I trust you when you say it's super secure.
It is. The point is, combining those two approaches adds a whole new level of complexity, making it even tougher for anyone trying to break in. It's like having a high-tech alarm system, A&D a security guard protecting your data.
I like those odds. So we've gone from Sudoku puzzles to secret streams to quantum computers.
Yeah.
I'm starting to see why zero-knowledge proof is such a big deal.
Oh, it is. And this is just scratching the surface, believe me. The deeper we dive into Spot On and other applications of this tech, you'll see how powerful it really is. And it gets even cooler with Spot On, actually. They have this thing called the Echo Protocol.
Echo Protocol. Okay, that sounds familiar. Didn't one of our sources mention a connection to that small world phenomenon? Yeah, that 6 degrees of separation thing?
That's the one. So the Echo Protocol, it's this decentralized way of communicating. Basically, they encrypt the message and then they send it to every single node connected in the network.
To everyone.
Yeah, everyone. But here's the catch. Only the person who's supposed to receive the message, the one with the correct key, can actually decrypt it and read it.
Okay, so it's kind of like sending a message in a bottle. But instead of tossing it in the ocean, you're sending it to everyone in the network.
Mm-hmm.
But only one person has the right key to open the bottle.
Exactly. And that's where the small world thing comes in. Because, it suggests that we're all connected in some way with just a few links separating any two people.
Right, like the idea that we're all just a few handshakes away from the Queen of England.
Yeah, exactly. And the Echo Protocol, by sending the message to all these nodes, it's kind of tapping into that idea. Like, think of each node as a person, right? So the message might bounce around between several nodes, like passing through several people, before it gets to where it's going.
Oh, I see. So it's kind of like that game of telephone, but digital and super secure.
Yeah, kind of, except only the right person can actually understand the message. And this approach, where it's decentralized, it makes it harder to disrupt or intercept.
But like a whisper network, but global and unbreakable. That's pretty wild.
Yeah.
I'm curious, though, are there other examples where this whole interconnectedness thing is used for security? Like in the real world?
Actually, yeah. It's an idea that's been around for a while. Like even Marconi, the radio guy, he hinted at something similar in his Nobel Prize speech way back in 1909. And there's a short story from 1929, Chain Links, where the author challenged readers to find someone he couldn't connect to in 5 steps.
Wow. So people have been thinking about this for a long time.
Definitely. And then in the 50s, you have these two guys, a mathematician and a political scientist, Coquin and de Solipool. They were really into the mechanics of social networks, like how information spreads. They even did math to estimate how connected we all are.
Wow, so it's a pretty deep concept. It's crazy how all these things are connected. Cryptography, social networks, even literature. It's like a big web of ideas.
It really is. It shows you how innovation often comes from connecting things that seem totally unrelated at first.
So, okay, back to Spot On. Besides Echo, are there any other features that use zero-knowledge proof?
Yeah, they have Echo accounts, which are like secure friend lists. It's like a VIP list. Only people who know the credentials can connect. A web of trust, but independent of the encryption key.
So it's like a secret clubhouse. You need the secret handshake to get in.
Exactly. And it's a big boost for privacy. You don't have to link your public encryption key with your IP address like some other apps do. You don't have to announce your IP address to the network.
Another layer of anonymity. That's pretty cool.
Right. It makes it really flexible, too. Spot On can work peer-to-peer or friend-to-friend, so you can control who you connect with.
I see. They also have something called adaptive echo, too.
Right, adaptive echo. That's like adding another level of control. You need a specific cryptographic token to forward messages, like a secret passphrase. Only nodes with that token can get the message and pass it on.
So it's like a password for the secret handshake.
Exactly. It lets you restrict messages to specific groups or networks. Like all the nodes in a country could share a passphrase and messages couldn't get out to other countries without it.
Wow, that's impressive. Like a super secure whisper network, but geographically limited. With all this security, it sounds like it would be a nightmare to set up, though.
Well, actually, our source says it's really user-friendly. There's a setup wizard that walks you through the whole thing, generating keys and everything. You don't need to be a computer whiz to use it.
That's good to hear, because I'm already feeling a little overwhelmed with all this information.
I hear ya. But they've made it pretty painless. You can choose between a passphrase or a question and answer for login security. And it lets you confirm your RSA keys. Those are important for the encryption.
Sounds pretty straightforward. What about activating the software? Is that complicated?
Nope. It's all done through the GUI. That's the user interface. It's separate from the kernel, which is what handles all the connections and encryption. You use the interface to activate the kernel, and then it connects you to your friends or a chat server.
So the interface is like the control panel, and the kernel's doing all the work behind the scenes.
Perfect analogy. Connecting is easy too. You just type in the IP address of whoever you want to connect to, and Spot On does the rest.
That's pretty slick.
Ugh.
But all this security, it must slow things down, right?
Actually, the source doesn't say anything about that. It seems like Spot On is pretty efficient. They even have a LAN messenger feature.
LAN messenger? What's that?
It means you can use Spot On as a messenger on a closed network, like if you're having a LAN party or just within your home or office network.
Oh, so you could have secure chats with people on the same network without even needing the internet. That's cool.
Yeah, it's neat. Apparently, it uses UDP to automatically find other Spot On installations on the network.
Man, Spot On really does sound like it has everything. It's like the Swiss Army knife of secure communication.
It really does. And get this, it's open source.
Wait, open source? You mean anyone can see the code?
Exactly. So anyone can examine it, modify it, which is great for transparency. And it means the community can help develop it too.
That's huge. Open source is usually way more secure because there are more eyes looking for problems. And it means Spot On isn't controlled by any one company either.
You got it. It's a really good example of how open collaboration can lead to better, more trustworthy software, especially when it comes to security and privacy.
For sure. These secret streams, it's a really amazing example of what zero-knowledge proofs can do. Are there any other examples out there, like in the real world?
Oh, yeah, definitely. One big one is in the world of blockchain technology. You know about Zcash.
Zcash, yeah, I've heard the name. Not sure I know what it is, though.
Well, it's a cryptocurrency that uses zero-knowledge proofs to hide the details of transactions. So you can verify that a transaction on the blockchain is legit, but you don't know who sent it, who received it, or even how much money was involved.
So it's like sending money through a secret underground network. No one can trace it.
Pretty much. It's all about anonymity and privacy for the users.
Wow, that's cool. So we've got secure messaging with Spot On, private transactions with Zcash. Anything else?
Oh, there's lots more. Voting systems, identity verification, all sorts of stuff. And it's all growing really fast.
Sounds like it. So much potential. Oh, one more thing. Our source mentioned Spot On using a zero-knowledge proof of knowledge. What exactly is that?
Ah, good question. It's a specific type of zero-knowledge proof, and it's all about proving you have a piece of information without revealing the information itself.
Can you give me an example?
Sure. Imagine you need to prove to your bank that you know your PIN, but you don't want to actually tell them the numbers. That's where this comes in. You interact with their system in a way that proves you know the PIN without ever revealing the actual digits.
So it's like showing them I have the key to a safe without actually showing them the key.
Exactly. And it's super important for things like passwords and PINs, where revealing the information would be a huge security risk.
Like a magic trick. You prove you have the secret, but never reveal what it is.
Perfect analogy. That's the power of zero-knowledge proofs. More security, more privacy without losing trust or transparency.
Well, this has been quite the deep dive. We've gone from complex math to real-world applications like Spot On and Zcash, even a little history lesson.
It really has been a deep dive. It just shows how much potential this zero-knowledge proof technology has, especially for security and privacy in this digital world.
You know, it's a lot to wrap your head around, but it's pretty exciting stuff. And we've been using this term cryptography a lot. Maybe we should talk about that a bit more, you know. It's kind of the foundation for all this.
Absolutely. Cryptography is the bedrock. It's the science of secure communication. It's all about keeping information secret from the wrong people. It's like creating secret codes and ciphers and all that, yeah. Keeping messages hidden from prying eyes.
And it's been around for ages, right?
Oh, yeah, centuries. But today we're focusing on the digital stuff, you know, the modern applications of it all.
Right, because that's where things get really interesting. And our sources mention a few different types of cryptography. One of them was symmetric key cryptography. What's that all about?
So symmetric key cryptography is like, imagine you have one key that both locks A and D unlocks a secret. So both the sender and the receiver, they use the same key to encrypt and decrypt the message.
So it's like a shared secret code just between the two people involved.
Yep, that's it. It's pretty simple and it's efficient, but there's a catch.
There's always a catch, isn't there?
Right, because how do you securely share that key with the other person in the first place? Like, if someone intercepts it, the whole system's compromised.
Oh, that's a good point. It's like if you bury a treasure and give the map to someone, but then someone else gets their hands on the map, your treasure's not so safe anymore.
Exactly. So that's where asymmetric encryption comes in. It's also called public key encryption, and it solves that whole key sharing problem.
Oh yeah, public key encryption. I think we touched on that earlier, talking about spot on. Can you remind me how it works again?
Sure. Think of it like a mailbox with two slots. One slot is for sending mail, that's your public key, and the other slot for receiving, that's your private key.
So anyone can drop mail into the public key slot, but only the person with the private key can open it.
You got it. You can give your public key to anyone, but you got to keep that private key secret, super secret. That way, you don't have to worry about securely sharing a single key with everyone you want to talk to.
Makes sense. So that's much more secure than just having one key for everything.
Way more secure. And that's why it's used for like everything online these days. Email, online banking, all that stuff.
And it's also a key part of how zero-knowledge proofs work, right?
Right. It lets you verify information without giving away the information itself.
It's all coming together now. It's like a puzzle where only the person with the right private key can fit the pieces together.
Exactly.
So besides encryption, what other cryptographic tools are out there?
Well, our sources mention digital signatures and something called cryptographic hash functions.
Okay, those ring a bell. But maybe you can give me a quick refresher.
So digital signatures are like, think of them as an electronic fingerprint. They're a way to verify that a digital document or message is really from who it says it's from and that it hasn't been messed with.
So it's proof that the message is authentic and that it hasn't been tampered with along the way.
Exactly. And then you have hash functions. Think of those as digital shredders. You put something in, no matter how big, and you get out this fixed size output. It's called a hash.
And you can't reverse it.
Right.
Like you can't go back from the hash to the original document.
Nope, one-way process. And that makes them really useful for security stuff, like storing passwords safely or making sure data hasn't been changed or corrupted.
Wow, it's amazing how all these different tools come together to create a secure online world.
It really is. And, you know, cryptography is always evolving. Researchers are coming up with new ways to protect our information all the time.
Well, my brain is officially full after this deep dive, but it's been incredible. We've gone from zero knowledge of proofs to all the ways cryptography makes it possible.
It's been a great conversation. Really fascinating stuff.
And to all our listeners out there, we hope you've enjoyed this deep dive into the world of zero knowledge proof and cryptography. It's a complex topic, but it's more important than ever to understand how it all works. So stay curious, keep learning, and remember, knowledge is power.